In the making of this video, I realized something important. I was starting with calculators to try to put in something that didn't really make sense. So, as you can see in the video, I put the squared log, which again didn't work because the brackets didn't apply it the right way. And I was trying to prove a problem that I have on one of my sheets here where I have a unnormal distribution of logarithms for a data set of n, summated n and I equal to 0 or n, and that of a prime to the power of a number that equates to the inverse, which I've shown in some of my other equations, doesn't really apply for real solutions. It's complex numbers. So that's something I kind of failed to explain in the last videos for an important follow-up, or this is my important follow-up of this. So I put in log 4, 28, and, or what should be the right notation. And I got very confused because I saw on the number plane it was a massive number, and I saw that the solution didn't really apply as much as I'd hoped. So there's something that screams inconsistencies to me, and maybe it's I'm too slow, or maybe it's math is too slow for just in general people in the way they calculate things, because we of course do not know everything, and it is sometimes hard for me, honestly, to calculate things, because when I find one reason to believe such, that I become disorganized in thought and do not know how to go about it, since before this video I was trying to look up a bunch of calculators and none of them computed the log graph the right way. So one thing I was showing in this clip was for the domain, which was for real numbers, and that's very interesting to me because in my circular system theorem, I've been trying to connect all these fields as an intuitive person I believe to be, or I believe myself to be, and someone who likes making connections between different fields, even as the person just getting into the understanding of math, as I don't have a formal definition, and everything you can see here is completely myself. And Wolfram Alpha, while it doesn't compute everything it possibly can, it does the best it does, and it's fine. I'm happy with that. So I went back to this, and it says it's a transcendental number. So in the video I give a preliminary that shows what a transcendental number is. I apply that reasoning to the end, which I'll explain, and I'll just say now that I believe it's relating to the circular system problem with the 2 to 2 n-dimensional phase between R2 and R2n, where it may be possible R2n is actually a complex or hyper transcendental number. And there's something very strange I see going on in this math, and being someone with an informal definition and understanding of these things, it's hard to really wrap my head around what exactly is going on here. So I plugged in my method, which doesn't quite work because you can't say something is the point, like a decimal change in x. So what I was trying to do was compute the primes, or for one of the other little theory things that I had going on, which I found an interesting application in. If I go through all my math papers here, so over time I've been working through all these different fields and figuring out a bunch of stuff. So yeah, in this, I just went back and forth trying to find some logical way to find a plot for my graphs, and to no avail. Found the paper, and so in this little clip, I decided to take out the plus change in x, and it says that it equals n. So for log squared of n squared, which equals n, that would be transcendental, I believe, when I go to the definition by plugging it in. If I go back up to the top in the clip. And so a little quick something is that I computed some weird formulas for log squared of a number times the tangent of the number to a power, and I noticed something. I decided to choose only prime decimal points that gave me an about approximation for the number I was looking for the first 10 primes, like 2, 3, 5, 7, 11, 13, 17, 19, 23, and 31. So log squared 10, 10, 10 to the power of negative 0.2 is about 2. And I went down the list to negative 0.4, negative 0.9, negative 1.2, negative 1.1, or no, actually 9 isn't a prime, so not negative 1.2, negative 1.1, negative 1.35, negative 4, etc., etc. And I realized something strange is that each of those ends in a list, decimal list of basically all primes, or any primes that are in between 1 and 10, not including 9, that is, and 0 is not a prime. So it's very strange how those primes like 2, 3, 5, 7, 11, etc. turned up there. And I forgot to say that 8 does as well, but that's my mistake. And so 8, 9, and 0 are the irregulars, for an example, and that's something I was very confused about. So I went to transcendental number, and it says possibly complex, and for these problems in the logarithms, I've noticed that there's a sort of trend relating to how these are brought about in context, because you can see how there are complex plots that are equated into the mix of things, and not really sure where that branches from. Again, with as much of an informal definition and understanding as I have, I cannot base my understandings solely off of the key most applicable understanding. So I cut it there, and this is where I have the rest of the clips that I cut out and didn't choose to add. And something I'm very annoyed about is my inability to furthermore comprehend some of these important aspects, like why is there complex and real transformations in this? Why does it seemingly have something to do with circular systems, and why am I not seeing pi in here? Why am I calculating for primes using normal numbers and finding very, very close matches for numbers using decimals as best as I can, even though it's a real number for all real solutions, and finding repeating decimals with supposed primes makes me wonder if maybe other numbers are in some way not necessarily prime, but like a pseudo prime, like a meta prime or a pair prime, something that bends a logic, because for a transcendental number to be an integer is completely unheard of, and there are no things such as transcendental numbers that are integers. So I don't really believe I'm getting into something completely new. or what, but for all the calculations of close matchings to all the logarithms and different things, I would definitely say there's something going on that has no formula or has no proof, and I've never seen it anywhere. I've never seen it in any textbook, and the fact that I can find this very strange inconsistency is beyond me. Well, not beyond me. The thing is about that I also, as a informal learner, don't really get into it a whole bunch. So it's either I'm slow, too slow, and quickly comprehend things that make sense immediately and then jump to conclusions that don't apply, or something is being caught that I'm not really getting yet, and I'm discovering something that it just doesn't apply. Either way, I think it's very interesting and fascinating that I've caught on to these patterns, and I would love to look into them more. Without further ado, I really appreciate it. And if you'd like to check out my other videos, you can. I wish I gave a better definition for some of the things I'm looking for. If I can just work through some of these problems to figure out what I'm exactly looking for. It's an intuitist, I guess, to say. That would be more effective than just screaming into a camera with no plan in mind. So, anyways, thank you and have a lovely day or night, wherever you are.